Good morning and a warm welcome to my lecture on Analytical Hierarchy Process for Supplier Selections, a Practical Approach. I introduce myself as Dr. Rabindranath Bhattacharya, the Adjunct Professor of Gupta School of Management, Indian Institute of Technology, Kharagpur. This slide gives um, uh, a small resume of mine, which you can go later on, and I will skip to the subject. When I entered the industries around the 70s, when we were ranking the suppliers, it was based on a method called weighted method. What we had actually, we used to take criteria for the suppliers, say for example, quality, cost, delivery, service, etc. And we used to give certain weightage, and then from their performance on the shop floor or during supply of materials, we used to calculate the actual rating. How it was being calculated is given here. So we have two companies, for example, A and B. Factors considered are quality, price, delivery. Weights for each of the above factors is quality. For quality, we are given the weightage of 60%, price 20%, and delivery 20%. So if we multiply each of the values of the factors by their weights, we can derive ratings. That means we'll have to find out the values of the factors from their performance and compare this with another supplier. This is the input. So total quantity supplied for A, 10 units. Out of that, 8 units have been accepted. So price per unit is 10. Delay in delivery is 20% of the time it was getting delayed. So quality rating, I can always rate it as 80 because 8 by 10 into 100. Price rating, I assume here that he is giving me the best price out of all the suppliers. So it is 10 by 10 into 100, 100%. Delivery rating is 80%. So now I multiply the weightage by these numbers, quality rating for 80 into 60, then 100 into 20, 80 into 20, so it gives me 84. So out of 100, this company A has got 84. Now if you see company B inputs, they supply 20 units, but total quantity accepted is 18. Price per unit is quite high, it's $16, delay in delivery is 10%, and quality rating is 90%, price rating is 10 by 16 into 100, because his price is 16 compared to what A was supplying. So price rating is equal to the price ratio lowest divided by simpler price, and delivery rating is 90%. So if we multiply, we get a figure of 84.5. So from these figures, we can easily say that B is a better supplier. So his ranking is number 1, and company A has got number 2. Although company B has a very higher price for each product, but it goes higher because of the fact that we have given too much weightage on quality. Generally, quality weightage is not put above the cost. Just for example, say I have given this example. Now it's up to you to take the decision. Who will you keep and who will you get rid of? So during 70s, when I entered the industries, a weighted method was in vogue. And by the time we entered 80s, then weight plus judgment method was in vogue. That means most of the organizations, they adopted this method. Here they have got certain weightage, they've given certain weightage, and then they applied some judgment to find out the ranking of the suppliers. So let us see how they used to do it. Quality 0.4, delivery 0.3, price 0.2, service 10, and total points 100. So supplier rating is 3 by 5. So how you got 3? Actually, the judgment came in the picture. We put the judgment as per the Likert scale, which varies from 1 to 5. So 1 is the worst performance and 5 is the best performance. So the experts, they formed an opinion that this supplier should not get more than 3. So 3 by 5 into 40, so 24. For this quality, for delivery 24, price this. For service, you are seeing that it's good. If it is good, we'll give 100%. If it is fair, we'll give 70%, and if it is poor, we'll give 4%, 40%, sorry. So the total score, supplier A comes to 63, and similarly for supplier B rating, it comes to 80. So here we have used weightage as well as judgment. Now during 80s, actually, people started developing analytical hierarchy process. It developed, it got its impetus, or people started adopting it more during 90s. And here in AHP, the analytical hierarchy process is a structured technique for organizing and analyzing complex decisions based on mathematics as well as psychology. It was developed by Thomas L. Satie in the 1970s, who partnered with Ernest Foreman to develop expert choice in 1983. In fact, expert choice was in fact the software for this AHP, and has been extensively studied and refined since then. So background, what is the background? It represents an accurate approach because we are taking the opinions of the experts on the line and quantifying the weights of the decision criteria. So we are forming some matrices, and out of those matrices, we are finding out the weights of the decision criteria instead of fixing the weights beforehand. Individual experts' experience are utilized to estimate the relative magnitude of factors through pairwise comparison. So pairwise comparison is the basis of analytical hierarchy process. So pairwise comparison, by doing pairwise comparison, we formed a matrix. And each of the respondents has to compare the relative importance between the two items under special design questionnaire. Generally, it is Likert scale, but in AHP questionnaire, it varies from 1 to 9, and all odd numbers are generally taken, but even sometimes even numbers are taken for decisions where consensus is not there. So AHP has particular application in group decision making and is used around the world in a wide variety of decision situations in fields such as government, business, industry, healthcare, shipbuilding, and education. So, gentlemen, it has got a wide application, and I can tell you that we have used it in many applications in our industries. When I was working in TBS group of companies, for supply selection, we have used in HR, human resource development. In HR, we have used this. Say it is an HR example. We want to choose a leader. Now, Tom, Dick, and Harry, and these are the 3 people, and goal is choose a leader. Now, what is the weightage? Experience, 54.7%. For education, 12.7%. For charisma, 27%. And age, 5.6%. So age has got minimum weightage. So what is the maximum weightage? Experience. So alternatives are Tom, Dick, and Harry, and ultimately we found out these numbers. So who is the best leader? Dick is the best leader because he has got the highest score. So how you calculate all these things, we'll explain with a real life example. So suppose a firm wishes to buy one new piece of equipment. We purchase a lot of equipment from all over the world. We used to purchase it when I was in a TBS group company. And we had four aspects in mind while purchasing the machine: expense, operability, reliability, and flexibility. Now, competitive manufacturers of that equipment have offered three options: X, Y, and Z. Now, pharmacy engineers have looked at these options and decided that X is cheap and easy to operate, but is not very reliable. Y is somewhat more expensive, but is reasonably easy to operate. Similarly, Z is very expensive, not easy to operate, but is a little bit reliable than Y. But it's claimed by the manufacturers to have a wide range of alternative uses. So the experts, they form an opinion like this, because competitors, somebody offered X, somebody offered Y, and somebody Z. So they are forming an opinion. So, or this is called Delphi method, and a decision has to be taken to form the matrix. So before we form the matrix, we must understand the mathematics behind the HP, and the calculation techniques are to be understood. So its essence is to construct a matrix expressing the relative values of set of attributes. So what is relative importance to the management of this firm of the cost of equipment as opposed to ease of operations? Now, if you say that my cost of equipment is, say, 9 times more important than ease of operations, or 7 times, or 5 times, so you must put a number. Now, they are again asked to choose whether cost is very much more important, rather more important, or as important, so on down to very much less important than operability. Now, accordingly, you will have to ask criteria to criteria. Where do you stand? What is the number you can put? Now, each of these judgments is assigned a number on a scale, and that is called SATI scale, and it is shown in table 1. Extremely preferred numerical rating is 9, reciprocal is 1 by 9. So suppose if you give A to B as 9, then B to A must be 1 by 9. Similarly, very strongly preferred, you give 7, strongly preferred 5, moderately preferred 3, and equally preferred is 1, 1. So this is what is called SATI scale of relative importance. Now, intensity of importance, if I talk about intensity of importance, it's very common to use the odd numbers of the table. But the use of even numbers should only be adopted if there is a need for negotiation between the evaluators. When a consensus cannot be reached, so it raises the need to determine the midpoint as the negotiated solution or compromise. So basic assumption, a basic but very reasonable assumption, is that if attribute A is absolutely more important than attribute B is rated at 9, then B must be absolutely less important than A and is valued at 1 by 9. This pairwise comparison are carried out for all factors to be considered, usually not more than 7, and the matrix is completed. This matrix is of a particular form which neatly supports the calculations which then ensue. So intensity of importance, I have given an example. Suppose criteria 1 is extremely important than criteria 2, so I give a number of 9. Then criteria 2 is to 1 is 1 by 9. Criteria 1 is to 1 must be 1, criteria 2 is 2. So this is the form of matrix we are going to form for the examples we are going to show. So basic theory is there are n elements to be compared, C1, C1, C2, C3, etc. and denote the relative weight, and it is known by Aij of the order n, and Aij, if you put, then reverse of that will be 1 by Aij for I not equal to j, and this matrix is called a reciprocal matrix. The weights are consistent if they are transitive. That means Aik is Aij into jk for all ijk, for all ijk. Such a matrix might exist if the Aij are calculated from exactly measured data. Then you will have to find out a vector of the order n such that the whole matrix multiplied that by that vector will be equal to some values lambda into that vector. So W is said to be eigenvector of order n. So theory is, if it is not understandable or if you are not able to understand properly, don't worry, we'll go to the example and everything will be clear. Now, after the forming the matrix, it is necessary to check whether this is consistent or not. That means randomness has been taken into consideration or not. Am I comfortable with the randomness? If it is not, then the exercise is valueless or must be repeated. So perfect consistency must be there, and how we do it is done by consistency ratio should be less than 10%. So consistency ratio is much in excess of 0.1. The judgments are untrustworthy. So let us do an example. The criteria are A, B, C, D. So A compared to A is to B is 1/3, A is to C 1/9, and A is to B 1/5. Similarly, if we take B, it must be B is to A must be 1/3, and B is to B must be 1, B is to C, let it be 1, 1. And if you see C is 9, CA, since A to C is 1/9, so it will be 9. And D to A to D is 1/5, so this must be 5th. And D to C, since C to D is 3, so it must be 1/3. So like that you can form the matrix, and then you make the normalize the matrix. What do you mean by normalization? Normalization means I am converting into, I'm taking the total and divide individual elements, divide individual elements by the total of that column, and we get figures like this. So what I did originally, whatever numbers were there, I just divided by 18, 1 by 18, 3 by 18, 9 by 18, 5 by 18. So it comes to 1 by 18, 1 by 6, 1 by 2, and 5 by 18. Now, if you add up this number row-wise, you will get certain values. You get these values. Now, these values are called eigenvalues, eigenvector, which is nothing but average of this, all these numbers. So if you take average of these numbers, then this numbers, then this numbers, you will get this eigenvector, which is called omega. Now, what this eigenvector gives the relative importance of value of A, B, C, and D. So I can say A is 5.98%, B is 26.7%, C is 44% important, and D is 22.66% important. So C is the most valuable B and D are behind, but roughly equal, and A is much less significant. And for checking the consistency, what we should do, we should find out the eigenvalue. Now for eigenvalue, you will have to write down the eigenvector. From the previous slide, we can write down all these eigenvectors. This. These are the eigenvectors we took out from the previous slide and put it horizontally. And total sum we wrote at the bottom. And then if we multiply this to total sum multiplied by the eigenvector for each column and then add them up, we get the value of 4.23. So this is called the eigenvalue. So what is the utility of eigenvalue? Eigenvalue is used for calculating consistency ratio. Now consistency ratio is nothing but lambda max, which we have found at 4.23, minus 4 divided by 4 minus 1, it comes to 0.076. And consistency index we can get from this. Since the n is equal to 4, because it's a 4 by 4 matrix, so it's 4, and we get 0.9 from the chart, and 0.076 by 0.9, it comes to 0.0844, which is less than 0. That means it is less than 10%. So hence the judgment is consistent. So whatever matrix you form for AHP, you must find out the consistency ratio and compare it with consistency index and find out whether it is less than 10% or not. If it is not less than 10%, it is more than 10%, you will have to repeat the whole exercise and form the matrix again. So the objective of this presentation is to present, discuss and apply the principles of AHP in the prioritization and ranking of suppliers in a portfolio. So AHP is one of the mathematical models currently available to support the decision theory. So it becomes extremely difficult to find out the ranking when you have different criteria and different sub-criteria. Under each criteria you might be having 5 or 6 sub-criteria, and then it becomes very, very complicated. So don't worry, the software is available, you can easily, but you must understand the basic mathematics behind this. Suppose you have gone to a dealer to purchase a car. Now you are totally confused and you don't know how to purchase it. So what you should do? You should take the help of AHP. Level 1, what is the goal? Buying a car. Level 2, cost, comfort and safety. And level 3, you have the alternative car 1 and car 2. Maybe Mazda or some other car. So what you should do? I am comparing criteria to criteria, and my objective is to buy a car. So what weightage I must give to? Cost, comfort and style. Now I form the matrix. How do I form the matrix? So cost to cost, if I compare, it is 1, it should be 1. Comfort to comfort, it is 1. And style to style is 1. Now as a driver or as an owner of a car, I want comfort must be very, very important compared to the cost. So I'm a rich man and I have enough money. So I want more comfort than anything else. So I'll put a number of 7. And I also need a style. So cost is not very important to me. So style is, I have given a number of 3. So this must be 1 by 7 and this must be 1 by 3. And then I compared style to comfort to find out this number. So style to comfort, okay, important. So style is more important. So style, I'll put number 3 compared to comfort. So first job is over. Now how to find out the eigenvector? So I have already explained to you. Buying a car, I put the total summation here. I put the normalized matrix. That means this divided by 1.476, 1 by 1.476. So I have given these numbers and I've taken average values, and so I've got these figures. So criteria weight 66.9% weightage I'm giving to cost, and 8.8% to comfort, and 24.3% to safety. So this is the weightage I am giving the criteria before purchasing the car. Now the question comes that the method which we adopted for finding out the eigenvectors, is it perfect? Or what we studied in matrix in our graduation bachelor's level, graduation level, then was, how did we find out? If we go back to our college life and try to find out the eigenvalues, you will find that these are the values you will get. 2.76 for cost, 0.363 for comfort, and 1 for style. The question is, how did you get the number which you have seen earlier, 0.669, 0.088, 0.24? We have just normalized it. So we have taken total, and 2.76 by 4.123, it gives. So if you take these two numbers and divide by 4.123, you get 0.669. So eigenvector actual values, if you take the help of software or you do it manually, it will never come match with whatever you have used in AHP. But it will be somewhat different, but don't lose heart. You will have to take the total and normalize it, and you will get the result same as what you have found out. Maybe a difference of 0.05% or 1% maximum over there. So this is an approximate method, and it's a very good method for finding out the eigenvector. Now we are checking the consistency for this example, consistency checking, and same way we have done criteria weights we have given, total we have written and multiplied them and multiplied this two, and then added up all this, we get 3.008. And eigenvalue calculated comes to 3.007. Actual value is 3.008. So there's not much difference. So we can comfortably use this technique for, for ranking the suppliers. Excuse me. Similarly, we check the consistency. Lambda max 3.008 minus 3 divided by 3 minus 1, because here n equal to 3. Consistency ratio is CI by RI, consistency index divided by random index. So 0.004, whatever we have found out from here, and divided by 0.58, which you got from the chart, and comes to 0.006, which is less than 0.1. Now the question comes, once we have given the weightage of the criteria, how to select the car. So for cost, we'll have to car to car. Now we'll have to compare the alternative to alternative. That means car 1 to car 2. What is the importance level? For cost, we'll have to find out, and then for comfort, then for style. So we'll have to form a separate matrices for each of the criteria, comparing the alternatives. That means car 1 to car 2, I'm giving a preference of 7. I'm giving the importance number as 7. So similarly, I'll find out the priority vector or eigenvector, priority numbers or eigenvector for all these matrices. Now, if once you have got these matrices, what number we have got? The numbers we have got 0.875, 1.25, 0.1678, 0.33, and 0.1. This we have found out from comparing car to car, and criteria which we have found out from the original 3x3 matrix, and these are all 2x2 matrices. So the overall ranking, how will you find out? For overall priorities, we'll have to, for car 1, for example, what you will do, car 1, this multiplied by this multiplied by this multiplied by this, and you just add it up. If you add all these three, you will get 0.624 for the first car and 0.376 for the second car. Now this is the overall priority or overall ranking for the car 1 and car 2. If it is not clear, I'll again explain. We have found out from the original matrix the weightage for each criteria, which is given here in this row, and then for each of the criteria we have compared car to car and find out 3 matrices, one for cost, one for comfort and safety, and we have laid them together like this. Now from here we can easily calculate what will be the priority, overall priorities for X1, for car 1 as well as car 2. So it shows that car 1 is better than car 2. Now I have given a flow chart for this consistency index. So develop a model, derive priority weights, then check consistency. Then is CR, consistency ratio, is less than 10%. If it is not, go back and develop the model again. If yes, deriving local priorities for alternatives, derive overall priorities, then do sensitive analysis. That means if the priorities changes, that means overall weight changes, then how the model will behave, and then making final recommendation. So as an analyst, you must do all these things before you put the proposal to your management. So that is exactly what you will have to do with real life problems. So the hierarchy structure, if we made for 2-car problem, so buying a car was the first level. Level 2 is the cost, comfort, quality, safety, for which we have found out the weights. 66.9, 8.8 and 24.3. For car 1, car 2, that matrices priority weights we have given here. And then ultimately you get the preference or ranking of the cars by multiplying this by this plus this into this and plus this into this, and you get these numbers. So that is why I have indicated, I have connected this car 1, car 1, car 1 by these lines. so that you can put these numbers and add them up so you get the priorities. So it is 624, so car 1 is the best car. So who ranks first? So car 1 ranks first. So what is the sensitivity analysis? What I have done here, I have changed the criteria weight. So you must be seeing that 6.669, I have made it 0.333. And overall priority will change. Similarly, it's 0.5 for the cost, comfort 0.25 and style 0.25. Similarly, for another one I have done, keeping 0.4, 0.4 and 0.2 for the style in the fourth one. And if you see this priority is, here it is car 1 is better, here car 2 is better, and here car 1 is better, here car 2 is better. So if we plot it out, we'll see like this. So depending on the weightage, the priority also changes. So now we come to the problem of selection of suppliers. So I have taken a very simple problem. Which I have solved it using the same techniques which we have explained so far. So objective is selection of the new suppliers, criteria is quality, cost and delivery. Alternatives available are A, B, C, A, B, C, A, B, C. So for each criteria, it has got an effect on 3 cars, and for cost also it has an effect on 3 cars, and delivery has also got certain weightage on 3 cars. Now out of that, I'll have to select, rank the suppliers. So first of all, that as explained to criteria, you will have to find out matrix, and you take the average value and you get the eigenvector. So 21.3 for quality, cost is 70% and delivery is 8.6%. Consistency checking, the same way you go on checking the consistency, and it comes to 3.058, and here for 3 we can take the table, it is 0.58, so its ratio comes to 5%, which is less than 10%. Hence judgment is consistent. Now for quality, I'll have to compare supplier to supplier. I form another matrix. So far as the quality is concerned, supplier B has got number 4 and supplier C is 3. That means it's very important. Supplier B is more important than supplier A. Similarly, supplier C with respect to supplier B is superior, because here we see supplier B is superior to supplier C. So we have given a number of 2. But whether the numbering is consistent or not, so you will have to find out the consistency ratio and check it for all the matrices you will have to do it. Now from here we'll get the weightage for average eigenvalues, eigenvector for quality, and then for cost also we form the same way the matrix, 3 by 3 matrix, and we find the eigenvalue. So these are the values. For the delivery, we also form the matrix and taken the eigenvector, found out the eigenvector, and we found out the final values or rankings of the suppliers like that. So what we found out, that supplier A has got stands first, supplier C stands second, and supplier B is the last. But remember, you'll have to check the consistency for all the matrices you'll be dealing with. So if we take the hierarchy chart, it looks like this. Select a new supplier 1, criteria 0.213, 0.701, 0.085. And for this alternative supplier A, supplier B, supplier C, so if you add these three numbers, you will get 1. So out of 21.3%, 62.4% is taken by supplier A, 13.8% is related to supplier B, and 23.9% related to supplier C. So how will you calculate the ranking of the supplier A, for example? I'll have to do 0.213 multiplied by 0.624, then 0.701 multiplied by 0.624 plus 0.085 multiplied by 0.093. If I do it, then I will get the value of 57.9%, which is the highest among all these three suppliers. So gentlemen, we have arrived at the final figure. So 57 point supplier is the best, A is the best, supplier C is the second, and supplier B is the last. So best supplier is A, which fulfills 57.5% of our requirement. Second best supplier is C, and third best supplier is B. Similarly, I have given an example of project selection, a complex problem inclusive of some sub-criteria. This has been solved using software. So what are the alternatives available? New product development for international market, open an office in China, new local marketing company, move to new office, outsource IT infrastructure, new ERP software. So I'll have to select which one I should take up on topmost priority to make the project successful. So it's a fictitious AHP organization. So people from finance, strategy planning, project management area has been used. The following set of 12 criteria has been accepted and grouped into 4 categories. Let us see. So project selection, we have 4 criteria: stakeholders commitment, financial, strategic, and other criteria. Stakeholders commitment has got some sub criteria: team commitment, organization commitment, project manager commitment, etc. Financial, return on investment, profit, net present value, etc. Strategic, improves ability to compete in international markets, improves internal process, improves reputation. Other criteria: lower risk, urgency, internal technical knowledge. So these are the criteria, and these are the sub-criteria. So let us see how the problem has been solved. So this is the first matrix. So criteria to criteria they have compared, and eigenvalues the same, eigenvectors they have found out, and approximate eigenvector and exact eigenvector has been compared. It's hardly 1.32%, 0.48% difference, so that you can easily apply. And it has come like this. So weightage has come like this from the software. Inconsistency is 2%, which is less than 10%. Now other calculations involving the chosen criteria. Now this criteria, there are 12 criteria, 3 into 4. So how you get the result that the global priority level you can find out from here, which I am explaining with a hierarchy chart. So select project is 1. Stakeholders, these are the main criteria, these are the sub criteria, and I have put the alternative like this. So final ranking will be summation of 12 numbers. 12 numbers means stakeholders, team related to stakeholders should be multiplied, and here it is 18%. So 18% multiplied by 6.8%. Then similarly for financial, sorry, So for each alternative, I'll have to go for this team, organization, and project. So first of all, this multiplied by this, and then multiplied for the alternative. What is the for alternative with respect to sub criteria? What is the weightage? So I'll have to multiply the three items together and to get the final number of this. So for each alternative, I'll have to get the numbers like this, the way we have done for the previous one. So see the calculations. For 4, I have done the calculations. Move to new office is the project, and after calculating all priorities and inconsistency indexes, it is possible to determine the relative weight of each project for each sub-criteria. And let us see this one. For team commitment, the first one, this is the result. For organization commitment, this one. For project manager, this one. And for return on investment criteria, this one. So like this. And for profit, this one. For net present value, for ability to compete, improves internal process criteria, and then improves reputation criteria, etc. And similarly for all 12 items, you can get these results. So I've given calculations for this one, for this move to new office, which comes to 0.0992. So I'll go back to the previous slide, hierarchy chart. This is the chart, move to new office. That means for each one, for team, organization, project, you will get certain weightage and then multiply these three weightages, this, and this. You will get the final number 0.992. And this is the final number for the alternatives. And here what we are finding, the move to new office is the most important, and the new product development for international market is also important. So these are the two areas where the company will have to work. Sorry. This is the final result. So 6 alternatives. So new product development and open an office in China. These are the two areas where you should work to make the project successful. So the proposed methodology can be utilized for selecting alternative decisions related to production planning decision, product development process, order production, logistics management, site selection, so whatnot. But this article provides the initial step in the process. Good news, a lot of softwares are available, expert choice, super decision lines. Conclusion, the results of 3 or 4 level AHP framework is able to assist decision makers to examine the ranking of suppliers as well as strengths and weaknesses of suppliers. But remember, the efficiency of this will depend entirely on the accuracy and the value of the judgment provided by the expert. So you must consider those people who are experts in the line. Way forward, now this techniques for order preference by similarity to ideal solution, TOPSIS, is another multi-criteria decision analysis, which is originally developed by Wang in 1981 with further developments by Woon in 1987. So TOPSIS is based on the concept that the chosen alternative should have the shortest distance from the positive ideal solution and the longest geometrical distance from the negative ideal solution. So my next lecture will be on TOPSIS. So these are the references which you can go and find out. I will ask you to solve this problem yourself and get a feel of this. Thank you, and write to me for any question whatever comes to your mind. Thank you. Stay safe.